Hi, in this video I'm going to demonstrate my workflow 3D scanning this construction job site using SHARE S20, a LiDAR scanner. So when I scan the construction site, each point cloud will has the GPS coordinate, and then I can use that coordinate to align the column center line so that I can locate the base plate of the column by using the RTK lower. So the position of the base plate and the location of the fixing point is very critical for the prefabricated steel structure. As you can see here, all the steel structure components are prefab and it has to be erected on site. Okay, let's start with the 3D scanning. This construction site is in Phuket. It's a hotel, rooftop of a hotel, and it's very sunny in January. The temperature is somewhere around 26-27 degrees Celsius. I have 54 satellite reception, so I should get a very accurate result. And this job site is very small, so it will take only a few minutes to scan, and we will see how accurate the SHARE S20 RTK will be.อย่าเพิ่งเข้ามาครับอย่าเพิ่งเข้ามาเสร็จแล้วครับเสร็จแล้วเชิญเสร็จแล้ว Because I don't have side office, so I need to do this in a coffee shop, and the Starbucks they allow me to plug in the laptop. Unfortunately, my laptop broken down, so I had to went out and bought the screwdriver, open up the back cover, remove the batteries, reset the RAM, and it's come back to life again. Because my flight back to Bangkok is in the next 3 hours. Because the scanning time is only 2 minutes, so the processing time is also shortened, less than 5 minutes. Okay, this will be the 3D scan result in the SharePoint Cloud Studio. As you can see that I can clearly see the position of the fixing point, and the corner is not that round. It's not as sharp, but it's not that round. If the plane is large, you get sharp corner. And this is not SLAM, this is RTK fusion. Because the time difference when I walk is very small, so the RTK fusion will give the result as good as the SLAM. If I scan a larger area, like more than 15 minutes, and then I come back to the starting point, the starting and the end point will have more earlier because it's a different time and the atmosphere is changed, so the earlier from the RTK will be higher than scanning in a small job site like this. The floor is blown out in white color. Let's check the photos. Okay, this will be the photograph from the left camera. Let's scroll down quickly. It's taken every 2 seconds. So you can see that part of my foot is captured. So sometimes you're going to see part of your body project onto the floor. Okay, this is the point where it's blown out. Everything is white. I import the point cloud into AutoCAD. This is AutoCAD. And each point we have a GPS coordinates, as you can see here. When I click on the point ID, it's going to show the GPS coordinate NE and Z. So next, I'm going to import the column center line. I align it to the scan data using the structure wall of the swimming pool as a reference, because I know that under the wall of the swimming pool there's going to be a structural beam landing along here. When I made the design of this structure canopy, I used the provided architectural drawing, but when they actually built this building, there are going to be a construction error. I'm trying to minimize the construction error so that I can still install this structure. One thing I can notice that this wall here is not aligned properly. See, it's about, if I measure the length, 3 centimeters, I can tell that this column is going to clash into the wall. This column is okay, and I can see that this column here is supposed to be sit over the curb, but now this 2 column will be outside of the curb. So I'm going to make a report to my customer and telling them that there will be a construction error and they need to accept this because they asked me to produce it according to the architectural drawing. I didn't come to survey the job site before I make the shop drawing, but everything looks perfect. I mean, the edge of the swimming pool wall is perfect in the dimension. If I turn off the point cloud, so I have already aligned this column center line to the GPS coordinate, right? To the point cloud with the GPS coordinate. So each line will have GPS coordinate as well, every line. So I'm going to export this column center line as a DXF or DWG format, export it into my loader, and I'm going to use it for positioning the location of the base plate. Okay, this is my RTK rover. I connect it to the carbon fiber pole. The length is 2 meters. The lower we connect to the controller which run on the Android. I have already imported the CAD file into this controller. Now I'm calibrating the IMU sensor by checking it around like this. Now the lower is taking me to the first base plate. When it's reaching the spot, it's going to show the error value, and the controller will tell me where to move left, right, front and back in a millimeters level. You will need only one person to do the stakeout, unlike the total station that you will need at least 2 persons, and it's faster and more accurate than the total station. I have about 10 columns to mark. Are you Richard?
Sorry?
Are you Richard? No?
No, I am Levent. What is this?
I'm a roof contractor.
Oh, this is for the installation of the fitness,
yeah.
Okay, when are you guys starting?
They can come on Wednesday.
Oh, that's late, no?
Yeah.
Later than planned, huh?
I'm setting up the base plate for them, so they know where the base plate will be. Okay, that was my customer. I just excused him for the delay of the project. Maybe I spent too much time making the YouTube video. Okay, this is one of the problem. The control box is not supposed to be here. This is the position of my columns, and it just put right above the base plate. See here, this RTK rover can lean about 60 degrees because it has IMU sensor, and this will be the last base plate to stake out. And this power outlet also clashed with my columns. I have it removed later. Okay, that's it. That's it guys for watching. I'll see you in the next video.